I am from Brazil, and this is my project. It's a sign language project. It translates English to the American Sign Language gloss. I said gloss, not class. No, gloss, not glass. There we go. So what you just saw was my latest project, an AI that can translate from English text to ASL gloss. And in this video, I'm going to show you how I built it and how it works. So let's start by the beginning. So like in my last post, I had built basically an AI that can pick up 4 signs from the Argentinian sign language. So you sign on the screen, the AI is going to analyze the video and it's going to speed up a sign, 4 colors. And yeah, here I detail everything. And that's basically a part of my journey in sign language recognition. And now I'm here with this project, which basically is acting in another stage of the pipeline of sign language translation. And everything starts here. Like sign language is much simpler than common language, and some signs they don't have like a direct translation to English. So for example, the example that I gave here is today is Friday. Like if you're going to translate that to ASL, you would do the signs now, day, and Friday. So the sentence in gloss, in ASL gloss, is now, day, Friday. And that's the written representation of it. Here are some other examples, as you can see. So what is your name gets translated to name you what, and this thing here, WH, he doesn't like pizza, get translated to pizza, IX/boy, doesn't like. So yeah, as you can see, it's pretty different. And so many works, many papers consider translating to sign language to gloss as a more efficient step than just translating directly from sign language to text in English, because that turns out to be like a simpler task, dividing tasks and then developing them, making them each one of them more efficient. So this is what the article is about. And this is the data set that I used. It's the ASLG containing like more than 87,000 sentences in ASL, actually in English, translated to ASL Gloss. So it's available on Hugging Face. And as you can see here, for example, we have other translations like members of the parliament, see minutes, get translated to membership, parliament, see minute, yeah, membership at the beginning. So as you can see, some words like of, they just disappear. They're not used in ASL Gloss. And that's like one of the key differences in sign language gloss. So I used a deep learning architecture called transformers. And this is like the original image from the paper that I replicated this project. As you can see here, I made the link available in the article too. And yeah, as you can see, it's got the same image here. And like this thing can like be reduced to only this. Like this is, I think, the part where it's interesting to know, because you see the transformer has 2 main parts, the encoder and the decoder, right? And the encoder basically translates a sentence in ASL, I mean in English, to a language that only the AI can understand, and that language is spoken through numbers. So for each word, there is assigned like a list of numbers called vectors, and those vectors represent and describe the word for the model. And now that the words are translated to this abstract language, they have to be, translated to another language, but that language is not going to be English. It's going to be gloss, ASL gloss. And that's the job of the decoder. The decoder basically takes the input of the encoder, as you can see here, we're taking like these arrows basically represent that the the output from the encoder, sorry, is getting thrown at the decoder, and the decoder is going to look at the beginning of sentence token. It's basically like a word that tells it that it's beginning to translate. So this token is going to tell that to the decoder, and the decoder is going to output the word it thinks that will come after it. So since we're beginning translating, the decoder will output something like now. And then the output of the decoder, in which case now, will get attached to the beginning of the sentence token, which was the previous token. And those are going to form the beginning of a sentence. And this sentence is going to be thrown inside the decoder again. So this is actually happening in a loop. I just unrolled the loop here because it looks more easy to understand, right? So we basically get this sentence and throw it in again, and now it outputs another word that it thinks that will come next. And then we do that again and again until the end of sentence token is outputted, which is this thing like here. Like sometimes we see like EOS, end of sentence. Sometimes in my case I use just end, and for BOS I use start. But it's just like a way to represent that this is the beginning and this is the end, and just a way to make sure that the decoder knows it. And that's basically it. I didn't put the code in this article, in this paper, because it's too much code. But if we click it, we're going to see the last successful run of this model. And here in the medium, I describe everything that I did. So we download the data set, we tokenize everything, we pre-process the text. So we basically, as you can see here, we have some characters in the class and text that after we pre-process, they just vanish, like /n. We take those out because they're not relevant. We also take out punctuation, like here we have desk previews, and here desk previews is just glued together without a dash. And yeah, after that we tokenize data, so we basically assign a number for each word of the model vocabulary. So as you can see here, membership gets translated to this like number, parliament gets translated to actually membership here on text, because here is tokenized, this is tokenized text column and this is tokenized gloss column. And one thing that's really like a consequence of what I just explained, is that we have to assign the beginning and end of sentence tokens to the gloss too, so that the model can look at those and automatically know that the gloss translation always start with the beginning of sentence token and end of sentence token. And those 2 and 3 are doing exactly that. As you can see here, the tokenized gloss examples always start with the 2 and always end with the 3, because those are the beginning and end of sentence tokens. And yeah, that's why there are like, they always begin with 2 and 3, even though the gloss that they represent are like not like that, like they don't start and end with the same word. So then I just trained it, and these are the graphs that I got. I mean the curves. Those are pretty satisfying to see, because it means that it worked, and it is usable, as you could see through the demo. I added the demo here too. And yeah, that was pretty much it. As I said, here I put like all the code for it if you were interested to see. And as it's on the end of the Medium article, I am very happy to have learned so much out of this experience. I didn't know what transformers were before I started to do this project, and now I feel prepared to tackle other stuff like that too. And if you want to directly reach out to me, connect on LinkedIn. I have my email here too, and there's also a monthly newsletter that I'm going to attach all of that in the video description, so that you have all the links that you need. And thanks for watching.